All right, now we're moving on to 11.4, the area of regular polygons. So that's all the sides are congruent, all the angles are congruent, and then composite figures are where it's got, if you remember, it's more than one shape put together. And you may have to break it down into those individual shapes, and then when you're finished, add together all your different sizes, and then that will find your area. All right, the new word that's going to come up that you haven't used before, the apothegm. That is the line that goes from the center of the circle and bisects one of the sides. That's the apothegm. All right, so let's have a look at what the shape is. As you can see, you've got a regular polygon here, and the radius is whatever AP is. Okay. And then in the blue, you've got the apothegm. And don't forget, the apothegm must be at right angles. It's a bisector, so it must be at right angles. So as you can see from the radius and the apothegm, and obviously part of AF, you've got a right angle triangle. So things like Pythagoras is going to come into it, trigonometry is going to come into it, or special right triangles. And now we're looking at completely at example 1. All this is identifying segments and angles. So in other words, naming the parts of the regular polygon and also parts of the circle. So here's question number 1, naming the parts, identifying the center. Well, the center is F, and don't forget it's the center of a circle, so you need to put the little circle in the target. The radius. You've got 2 here. You can either use FC or you can use FD. The apothegm, that's only one. There's only one there, which is FG. And the central angle, don't forget an angle is 3 letters when you've got points. So don't forget, F is a point, it's not an angle. So it's CFD would have done. Okay. You could have had CFG, you could have had DFG, so any of those would have fit. And now we're having a look at example 2, a stained glass window. If you can see, it's an octagon, but again, if you break it down into triangles, you know that the apothegm is 18.1 and the triangle itself is 15, the base is 15, so you can use that information. Your triangle is a half base times height. Look, that's not changed. So each triangle, and don't forget the triangle is the yellow part here, so each triangle is 135.75. Okay, and like I said to you, it's an octagon, so you need to multiply that by 8 and you're going to finish up with 1086 square inches. All right, so let's have a look at question number 2. Find the area of each regular polygon. Well, it looks a bit complicated, but it really isn't. If you draw your apothegm, and don't forget it goes to each of these is a right angle. Well, it's a regular polygon, so this guy must be 60 degrees. All right, and this must be 30 degrees. Now we can get the information. We know the base is 6 because it's regular. But this, don't forget, the shorter leg is half of the hypotenuse, so this is 3, and the apothegm is 3√3, or the height in this case. So now you've got the formula A equals a half base times height is equal to a half of 6. That's the base, and the height is 3√3, and you're going to finish up with 9√3. Which, if you put that in your calculator, you'll get 15.58. Well, it does say to the nearest tenth, so it's 15.6. And it is meters or miles squared. Okay, so here's from example 2, and then developing the formula. Don't forget your formula is a half base times height. Well, if you use the letters that they've given you, so S for side and A for the apothegm and P for the perimeter, you'll see that you can eventually change your half base times height and it will go to a half AP, a half times the apothegm times the perimeter. Okay, you can use either of these, but that's the one that's in most textbooks. And here's where you start using that formula. Okay, it's a regular polygon, it's a hexagon. So the angle ABC is 60 degrees. And again, you can break this triangle ABC down into this, just like I did in the previous question. And as you can see, you've got 30, 60, 90 triangles. You can work out what each side is and what the apothem is. Put it all into the formula. A equals a half AP. So the apothem we already decided was 1.5 root 3, and you've got 6 times 3 will give you 18 for the perimeter. Put it into your calculator, you get 23.4, and again make sure that you read the question round to the nearest tenth. And so here's example 4. We are finding the area of a composite shape. Well, have a look at the shape you've got here. Okay, you've got a semicircle here, you've got a triangle here, and you've got a rectangle here. Separate it down. Me personally, I number them 1, 2, 3. Find the area of number 1, a semicircle. Okay, it's pi r squared, remember, so it's a half of pi r squared, so 16 times pi, so 8 times pi will give you the semicircle. And again, you've got a right angle triangle. You know that you've got 4. Can you make the distinction that it's actually a isosceles triangle? You're not quite sure, so do Pythagoras. 5.7 squared minus 4 squared will give you this. You can then find the area of the triangle, and then obviously the rectangle is the easy one. It's length times 4 times 7. Alright, so let's have a look at number 8. Find the area of each figure round to the nearest tenth. Simplest way, it's entirely up to you which way you go, but personally I'm going to go this way. Alright, label it 1 and 2. They're both length, the area equals length times width. Okay, so area 1, so that's what I do. Area 1 equals 7 times 20, which is 140. And area 2 is equal to, now you've got to work this one out. So you've got your 11, which is there, but your length is 16. Well, you've already used that 7. So this guy here from here to here must purely and simply be 9. So that's 11 times 9, which will give you 99. And then I put total area is these two guys added together. Okay. So that's 239, and it's feet squared.